All right, so today is kind of the bread and butter of secondary math 2. This is, I would say, the biggest day of the year of everything you learn. I think this one is the most important method and most important thing that we're going to do this whole year long. And it involves a lot of what we've done already kind of wrapped up and then used to solve something. So what we're doing is we're solving quadratics by factoring. And this relies on something called the zero product property, which sounds scarier than it is. The zero product property, remember, just says that if A times B is equal to 0, then A or B is 0. If two things multiply to be 0, one of them has to be 0. And we use that to solve quadratics. So here's what we do. Step 1, you set the equation equal to 0. Step 2, you factor. And that's kind of where it starts us off right here. It's already set it equal to 0. It's already factored this problem for us. But what it's having us do to use this zero product property right here is x minus 4 inside these parentheses is being multiplied by x plus 1. And when you multiply them together, you get 0. So that means that one of the parentheses has to equal 0. So x minus 4 can be the one that equals 0, or x plus 1 can be the one that equals 0. So to make x minus 4 equal to 0, when I add 4 to both sides, I get x is equal to 4. To get x plus 1 to equal 0, I minus 1 from both sides, and I end up with x equals negative 1. So I have two answers, x is equal to 4 or negative 1. And we can write that in our solution set or that form that we talked about last time, okay? So the important thing is setting it to 0, factoring, seeing what makes each parenthesis equal to 0. So we're going to go through a couple of examples step by steps. I know that was really fast. I'm okay with that because here's what I really want you to be following along with. So it gives us this quadratic right here, x squared minus 3x minus 10. First thing that we need to do is set it equal to 0. Well, right now it's equal to f of x, so it's pretty much equal to 0. Step 2 is to factor the quadratic. So we talked about how important it was to learn this x method, where I'm trying to break this up into two parentheses that multiply to be each other. So I'm looking for something that multiplies to negative 10, but adds up to negative 3. So I know one is a positive, one is a negative, and I'm going to say negative 5 and positive 2 because I multiply those to get negative 10, and I know that the negative is the bigger one because when I add them together, I get a negative. So those add up to negative 3. So what I end up with is x plus 2 multiplied by x minus 5, and we're setting that equal to 0, which means this one can be 0 or this one can be 0. Well, let's say it's this one. Let's say x plus 2 is equal to 0. So if I minus 2 from both sides, that means x is equal to a negative 2. And if this is the one that is equal to 0, x minus 5 could also equal 0. And it doesn't matter what happens to this one, as long as one of them is 0. So if I add 5 to both sides, x is equal to 5. So I have two x's. X is equal to negative 2 and x is equal to 5. Now remember what that looks like on a graph is that's where I cross my x-axis. Okay, that's why we call them x-intercepts. Or there's a couple of other phrases up here that you're going to want to remember. These solutions are called x-intercepts. They're called roots. They're called zeros. Or we just call them the solutions. Okay, so right here, x is 5. Yep, my y is 0. And right here, when x is negative 2, my y is 0. So those are my two solutions. And you can either write them like we did, or you can write them in the solution set as -2, 5. Okay. All right, so a couple more examples. Like I said, the biggest thing here, I think, is going to be working through a few of these. So f of x equals x squared minus 8x plus 16. So we're going to set that equal to 0, and I'm going to factor. So I'm looking for two things that multiply to 16 but add up to -8. That one's not too bad because it's just -4 and -4. I know they're both negatives because they times to a positive, and they add up to -8. So I've got -4 and -4. So what that means is I've got x minus 4 times x minus 4 equals 0. So this could be 0 or this could be 0. So x minus 4 could equal 0, which means when I add 4 to both sides, x just equals 4. But this one gives me the same thing. X minus 4 equals 0. So when I add 4 to both sides, I get x equals 4. So technically, I got two answers, but they're the same answer. And remember, that's what happens when the graph just touches the vertex, the x-axis right here. When my vertex just touches it in one spot, both of these are going to be the same because it just touches it in that one spot. It's the only one solution to our equation, all right? It's the only one, well, it's the only one solution when we want y to be 0. So if you've noticed, when you get your parentheses really quick, you can figure out the answer because it's just the opposite of whatever's inside your parenthesis. Like my parenthesis was x plus 2. My answer was just -2. And this one was x minus 5. My answer was 5. So when I look at this graph up here, it crosses at 3 and it crosses at 9, which means my parenthesis, one of them is going to be x minus 3. Can you guess what the other one's going to be? It's going to be x minus 9. It's going to be the opposite of whatever's in the parenthesis because it crosses at 9. Okay, so it gives us a few examples right here. We'll go through these and then I'll show you a few more. It wants us to match the graph with what we get when we factor these. So this first one might be a little bit tricky because there's no c. Well, technically there is. It's just a 0. So when I do my x, I've got to take this 5 and times it by 0, which just means I'm looking for two numbers that multiply to 0, but they add up to 10. Well, if they multiply to be 0, one of them is 0. And if they add up to 10, the other one has to be 10. But don't forget we multiplied by 5, so I've got to divide by 5 and divide by 5. This stays 0. This one becomes 2. So my answer is x plus 0 and x plus 2, which really this one just turns into x times x plus 2. So what I'm looking for is the opposite intercepts. I'm looking for, well, the opposite of 0 is just 0, and the opposite of positive 2 is -2. So my x's are going to be 0 and -2. So when I look at these three graphs, this one crosses at 7 and 9, not that one. This one only touches once at 3. This one crosses at -2 and +4, but this one crosses at -2 and 0. So this would be my graph. That number 1 would be graph D. Okay. Number 2, x squared minus 6x plus 9. So what multiplies to 9 and adds up to a -6? Again, they're both negatives, and this one's going to be -3 and -3. So my answer is going to be x, well, not my answer. My next step, my factor is going to be x minus 3 times x minus 3 equals 0. So one of these has to be 0, but they're actually the same thing. So x minus 3 equals 0. If I add 3 to both sides, then x is equal to 3. But because they're the same, that's the only place it's going to touch the x-axis, which was this one right here, C. It only touched in one place at 3. So my answer to number 2 would be C. And then number 3, x squared minus 16x plus 63. Again, I draw my big X. I put 63 on top, negative 16 on the bottom. So I've got a positive and a negative that are going to add up to be negative 16. And it means my bigger number is going to be the negative because when I add them together, I get a negative. So my options, I'm going to start a list right here. My options are what? 1 and 63, but that would be a negative 63. 3 and negative 21. That gets me close. That gets me to negative 18. How about negative, oops, we were keeping positive on this side, huh? I was going to say 7 and 9 gets us to, but that would be a negative, so that would be negative 60. Oh, they multiply to be a positive, sorry. I was thinking we had a negative right here. So one of them is not a positive. They're both actually negative. I'm going, wait, this isn't adding up because I wrote the numbers down wrong. It's negative 7 and negative 9 because they add up to a negative but multiply to a positive. So I get x minus 7 and x minus 9. And for those of you that are starting to see the shortcut, if x minus 7 is my parenthesis, then x is 7. And if x minus 9 is in the parenthesis, a solution is x equals 9. So I'm looking for A. I'm looking for where they cross at 7 and 9. Okay, let's do a couple more examples. What happens if it's not equal to 0? Well, then I just make it equal to 0. I would just minus 24 from both sides. So I end up with x squared plus 2x minus 24 equals 0. So I'm looking for two numbers that multiply to negative 24 but add up to 2. So this time, correctly, I know there's a positive and a negative. The positive is going to be the bigger one because they add up to be a positive 2. So factors of 24, we do this one quite a bit. 1 and 24, 2 and 12. I need to get closer than that because they're only 2 apart. 3 and 8, 4 and 6. That looks promising. And the negative is going to be the little one, the 4. So negative 4 plus 6. So my factors are x plus 6 and x minus 4 are what multiply together to equal 0, which means this one is 0 or this one could be 0. So if I take the long path, x plus 6 equals 0, minus 6 from both sides, that means x is equal to negative 6. That's one solution. And now if this one was my 0, I add 4 to both sides. Whoops, add 4. X equals 4, my other solution. So my solution set is negative 6, 4. Those are my two solutions to make these multiply to be 0. Or they're my roots, or they are my zeros, or they are my x-intercepts, or they are my solutions. All those mean the same thing, okay? Now this one in the middle, we haven't done, well, we did 1 on the other side, but we have this number out in front of the x squared. So when I do my x factoring, I've got to remember to multiply those together. Yikes. That's going to be negative 168, and they're going to add up to negative 17. And we're going to pretend that we're going to set that equal to 0. So I'm looking for two numbers, a positive and a negative, because they multiply to be a negative. 168 is going to be what? Well, we know it's 4 and 42, but those don't add up to 17. But we could do 8 and 21. Those still don't get me to 17. How about, what else could we do? If this, what does 42 factor into? That's 7 times 6. So what if we do 12 times 14? Not even close. I'm getting too close together. So let's just try 6 times, what's 7 times 8? 7 times 8 is, or what's 7 times 4, I mean. So that's going to be 28. That's still not getting me there. I still need to be 17 apart. So how about 7? 7 and 24. There we go. 17 apart. And my negative's the bigger one. It's the 24. Maybe I should have figured that one out before we started the video. So I've got 7 and negative 24, but don't forget to divide by 4 because of this 4 that we multiplied by earlier. So when I divide by 4, that's as simplified as it gets, which means my parentheses is going to be 4x plus 7. This one, negative 24 over 4, simplifies to be negative 6. So this becomes x minus 6. So this one's really easy. We know that x is going to be 6, right? Because we're starting to recognize the shortcut. But be careful for this one, because for this one to equal 0, 4x plus 7 has to equal 0. So I have to minus 7, which means 4x equals negative 7, and then divide by 4. So x equals negative 7/4, which, look right here. Same thing, but the opposite sign. So there's my two x's. So my solution set is negative 7/4 and positive 6. Those are my two x's that get me 0. Now this last one is another one that isn't set equal to 0. So we just make it equal to 0 by adding the x to both sides. So this becomes 7x squared plus x minus 8. So this looks a little bit messy, but because this is such a small number, I think it's going to actually turn out to work a little easier than normal. Because when I do my big X, I've got to do 7 times 8, right? We moved the X over, so now we got to do 7 times 8, which is, oh, it's a negative 8, so that's negative 56. And they've got to add up to 1. And we know the bigger number is the positive because they add up to be a positive 1. Well, let's just use the numbers that we did before, 8 and 7. Those are 1 apart. So if I have a positive 8 and a negative 7, don't forget I've got to divide by 7, which gives me, this just becomes negative 1. So x minus 1 is one of my parentheses. My other parenthesis is 7x plus 8. And remember, those multiply to be 0. So for this one to be 0, we add 1 to both sides. X is equal to 1. For this one to be 0, 7x plus 8 equals 0. So I minus 8 minus 8. 7x equals negative 8. Divide by 7. X equals negative 8/7. So my solution set, my zeros are 1 and negative 8/7. Those are my zeros. Those are my x values that make my y 0. So we can look at that on a graph. If I put 7x squared, we didn't look at any of these on the back on a graph. We looked at the ones on the front, plus x minus 8. So when I graph that, this is what it looks like. And I expect to cross at 1 right there, and I do. And I expect to cross at negative 8/7, which is right here. But it's kind of hard to see that that's a little bit farther than negative 1, negative 7/7. We're just a little bit farther. So negative 8/7 sounds like it would be a good guess. All right. So what I would like you to do, homework 8C. You have, I think there's about 8 questions that I want you to try at home. If you get stuck, if you can't figure them out, we'll work on them in class. I'll answer questions. But when you come to class, expect to work on homework 8AB as well. We'll kind of expand a little bit on what we just did and do some story problems and other things.